All right, got your notes out? I know a lot of you are having fun with that throwing thing, but the point is that's not appropriate for the classroom. It was even in the class policies. Do not throw items. Okay. Yeah, you signed that you read it. So. All right, we're going to work on equations of lines today. Okay? We're going to use slope-intercept form and point-slope form, convert between one to the other, and probably a little bit more of that classifying, parallel, perpendicular, coinciding. So we talked about the three forms of equations yesterday. So I think this is 3-6 again that we're going to have, or 3-4. It's either 3-6 or 3-4. Okay, not 3-4, so 3-6 to start with, then we'll go to 3-4 later. So I talked yesterday about the standard form, slope-intercept form, and point-slope form. And we looked at, I think I gave you an example of standard form, like that it was ax plus by equals c. So here's one where actual numbers are there. 3x plus 2y equals 12 is an exact example of standard form. Why do we have standard form? It's because you have problems writing a vertical lines equation in something that requires slope, like slope-intercept or point-slope. Because what's the slope of a vertical line? Undefined. So there would be no such number you could use in that form. So a vertical line actually is from standard form. That's why it ends up being x equals instead of y equals. Point-slope form we're going to focus on a lot today. Point-slope form is a form that I think really helps if you're trying to write the equation of a line. Some of you maybe remember doing the method that kind of was on the bell ringer at the beginning where you had to find the b, and then you would end up rewriting the equation after you found the b. That is one method that we show in Algebra 1. I found that I think I like the point-slope form because you don't have to substitute in, find something, and then resubstitute to remember how to write the equation of the line. If you substitute in the slope and a point it goes through, and then just simplify, you can get to slope-intercept form easily. So I'm going to be using point-slope form, especially as a starting point to write the equation of a line. Once in a while, I'll let you just leave it in point-slope, but sometimes we'll simplify it. So point-slope was y minus y1 equals mx minus x1. Okay, the m represents what? Slope. It's always represented slope. That's still slope. The x1 and the y1 are one of the points that the line goes through. You will substitute in for x1 and y1, but you won't substitute for the plane x and the plane y. Because when we simplify, we want those variables x and y to stay there to represent all points that could be substituted. Not just one point, but multiple points. So an example for your notes, if the slope is 2 and the point we want our line to go through is 4, 3, by substituting in, we get, the 2 goes there, the 4 and the 3 go here. Y minus 3 equals 2x minus 4. That is point-slope form. Sometimes we'll simplify that into slope-intercept, but not all the time. So point-slope really is pretty simple. So I want you to give me a sample here. Show me that you can substitute in correctly. Write the equation of the line that goes through the point, 8, negative 5. The slope's supposed to be negative 1/2. And I just want it in point-slope form. I think I'll ask you all to show me the boards at the same time so that I can kind of keep track better who has shown me and who hasn't. So just the point-slope form. Y minus whatever y1 is equals Show me back there, Nick. Well, I want to make sure you're doing it right, so let's see. I think you didn't get the negative on the 1/2. Okay, so that's what you have. Yes. So, you can simplify the minus negative to a plus positive. Okay, that one should end up being y plus 5. It was minus negative, so simplify that to plus. Negative 1/2, and the parentheses x minus 8. That's simply point slope form for the equation of a line. We could graph that. Maybe you want to simplify it to graph it, but that is something that we'll do. Okay, the slope intercept form we mentioned yesterday. Let's have you write the equation of the line if the slope is -5 and the y-intercept is -3. Using that form, what would the equation look like? Why am I using a different form? Because of the different information this time. Slope is -5, y-intercept is -3. What's the equation look like plugged into slope-intercept form? Read the description again. M is the slope, B is the y-intercept. That's where they go in the equation. Show me again. This should say y equals -5x minus 3 or plus -3. The 3 was a negative. So depending upon what information is given, we might choose a different form. Okay, horizontal and vertical lines, I mentioned those yesterday. Write the equation of the vertical line, look at your notes there, vertical line that would go through -2, 9. Would be the vertical line that goes through -2, 9. Vertical line, look at what the notes are telling you. Where would it hit the x-axis if it goes through -2, 9? Show me. You need one more. Well, is it x or y or what is it? Looking pretty good. Which one's the vertical line? The vertical line was x equals -2. What's the horizontal line that goes through that same point? The horizontal line that goes through that same point. All right, and show me, if you haven't yet. Those look pretty good, y equals 9. All right, so we did all those types. Now let's kind of mix it up a little bit. Write the equation of the line. The slope is 3/4, and it has to go through the point 4, 6. I want you to finish in slope-intercept form, but let's start with point slope because that's what we have. We have a point and we have the slope. So again, you can write in your notes if you want some examples, and I think you probably would be good to have some examples. So start with point slope. Fill in the point that you want it to go through. That's your 4, 6. Put those in for your x1, y1. That's one of the points we want it to go through. And then the slope is supposed to be 3/4. That's the m. So we've got y minus, what's y1? 6 equals, what's m? 3/4. Parenthesis, x minus, what's x1? 4. Putting in the point 4, 6 and the slope 3/4. Okay, now some of you are showing me already, just wait a second. I want you to finish in slope intercept. So now simplify this. This is what I've had to do a few days. Distribute the 3/4. And then after you've done that, add your 6 to each side. 3/4 times 4 over 1. Some of you are anxiously awaiting. Show me. Pretty good. That last number should be a positive 3. When you distributed, it was 3/4 x minus 3. Then you're adding 6 to each side. Negative 3 plus 6 should be positive 3 on the end. Questions to clarify? Okay, let's try another one. And again, I would suggest some of you be writing it in your notes and maybe just put your final equation on the board. Write the equation, ending in slope-intercept form. Let's start with point slope, because that's the information you have. You have a point and you have a slope. How to simplify that? Subtract negative 6 to a positive to a plus. Distribute your 2/3. All right, I'm looking up your boards as I'm walking around. The ones I've seen look good. Y equals 2/3 x plus 16. Two-thirds times 6 was how much? 4, and then you're adding 12 to each side. Okay, question on that one? Nope. All right, here's a little bit different one then. Write the equation of the line through -1, 0 and 1, 4. In the end, I want it in slope intercept. Now what's different about this one? What's that? Okay, I gave you 2 points, I didn't give you the slope, did I? Can you find the slope? Because you were getting good at writing it if you have a point and a slope. So first step is find the slope. Subtract the y's for your numerator. Subtract the x's for the denominator. what was the slope? Should be 2 for the slope. Okay? And then when you could use either point. So if someone used the other point, your work maybe looks a little bit different right there. But when you simplify, should have y equals 2x plus 2, no matter which sign. Doesn't matter which point you used, it'll simplify to be the same. Questions to ask on that one? Okay. Let's do one more of those with your partner. So which way have I been doing? Front to back? First row, turn around to the second. Third row, turn around to the fourth. Okay, and back to you, good pair up. Okay, let's give you 2 points. Let's go with 6, 8, and the point -4. Let's see. Yeah, I was going to put a 2. I don't know if that'll work very good. You'll probably run into a fraction. Write the equation of the line that goes through those 2 points and convert it into slope-intercept form. Work with your partner. We are going to decimal, it looks like. Okay, what was the slope? Okay, slope should have been 3/5. And I think in the end, the equation was y equals 3/5 x plus 4 and a 4.4? Or 22/4, or 4 and 2/5, yeah. Okay, do I need to show some work?
Yes.
Yeah. Did you get the slope right?
Yes. Yes.
Okay, if you didn't do the slope right, 8 minus 2 and 6 minus -4. That was 6 over 10, 3/5. All right, then whatever point you want to use, doesn't really matter. If I go y minus 8 equals 3/5 x minus 6, when I distribute here, y minus 8 equals 3/5 x minus, I did like 18/5. Maybe you went to a decimal right there. If you went decimal, that was what, 3.6? then add 8. And y equals 3/5 x plus 1. Do you understand what to do? Give me a thumbs up or down if you understand what to do. Okay, so for some of you, it's just getting the calculations. Okay, so what we were doing was we found the slope, and then we used the slope and a point. You could choose either point you wanted, and then simplified it. The simplifying is always the same. You're going to distribute, and then you're going to either add or subtract this number off to the right-hand side. We're going to be doing more equations, so let's see if we can get practiced at that as we go through some more things. So I'm not just going on, we're going to be doing it some more in a different situation. For the next part, let's review what's the slope of parallel lines, what relationship do they have? Parallel have to be the same. Perpendicular? They do intersect, but the slopes have to be opposite signs and reciprocals. In other words, if you would multiply them together, you get -1. Okay, that's important because here's the type of question now. Write the equation of the line parallel to y equals -3x plus 6, but through the point 1, -5. And I want it to end up in slope-intercept form. I would still suggest we start in point slope. Let's still start in point slope. So what point and what slope do we want our line to have? What point do we want it to go through? Read the problem. 1, -5. What slope do we want it to have? Well, it has to be parallel to this line. What's the slope of this line? -3. To be parallel, what'd you tell me just a second ago? Has to have the same slope. So the slope we want to use is -3. So write the equation of the line that has a slope of -3 and goes through the point 1, -5. Start it in point slope and convert it into slope-intercept. Read the directions. Because like on the worksheet that I'm giving you today, there are a few problems that I'm just letting you stop with point slope. But then there's some where I said put it into slope-intercept. Check with your neighbor, your partner, to see if you got the same thing. Agree? I haven't completely.
3 times -3 times -1 is 3.
Looks like it. What did you decide that last number should be? Is it an 8?
Is that right? That's what I got.
Did you have minus -5?
Yeah, and then it's,
Okay, and then you
oh,
would
okay,
subtract 5.
yeah, okay.
Okay, I think we're questioning a little bit what that last b value should come out to be. And I've got y equals -3x minus 2. How many groups had it right? Okay, quite a few. Some had a +8 or something, so our signs were wrong. Now remember what we did yesterday? When we were looking to see, are they parallel, perpendicular, or coincide? Okay, look at this equation and look at the one we just wrote. Based on yesterday, would you say those lines are parallel, perpendicular, intersect, or coincide? Why are they parallel? Same slope, but different y-intercepts. That's how the equations of parallel lines will end up. Different intercepts, but the same slope. Okay, let's try. one more of the parallel. Write the equation of the line parallel to y equals 4/5 x minus 2, but through the point 10, 3, and end up in slope-intercept form. If it helped, do what I did on that last one. List what is the point and what is the slope that I should be using. All right, check with your neighbor, partner. Okay. And it should be, make sure both of you didn't miss it. Y equals 4/5 x minus 5?
Yep.
Okay, hand up if you got it right. Okay. Did you miss it? Little off day. Okay, read the directions on this next example. Yeah, what's different?
Perpendicular.
Perpendicular. So what's that gonna affect?
The slope.
That's gonna affect the slope that we pick to use. Okay, so what point does it need to go through? It needs to go through 9, -5. What slope do we want it to have? Okay, so you were telling me to get perpendicular, it has to be the opposite sign and reciprocal. So the opposite sign would be positive, reciprocal. 1/3?
Yeah.
Instead of 3?
Yeah.
Reciprocate it. So the slope that you need to use is 1/3. Because you had to do the opposite sign and the reciprocal to make it a perpendicular line. See if we can get our distributing and adding or subtracting to end up with the right value. Okay, compare. Partner compare. Okay, how about y equals 1/3 x minus 8?
That's
Okay, I helped you figure out the slope on that one. Next one, I'm not gonna help you. You figure out the correct slope. Do we want it parallel or do we want it perpendicular? You gotta read the problem to see. Write down like what I did. What point do you want it to go through? What slope do you want it to have? We did the reciprocal. Opposite What's your slope? What do you have for slope? That's a good problem. Your slope should be negative. Reciprocal, yes, but opposite. Opposite side of the reciprocal. So that's going to change some positives and negatives, which is. Okay, as I'm looking, we did pretty well. A few things I had to clarify, but you should have had y equals -3/5 x minus 11. Because once you have that -9, then you're going to subtract 2 from it. Oh, yeah. All right. On the 3/4 lesson, perpendicular bisect. So flip to the 3/4 section. What a perpendicular bisector is, it's a segment, or it's a line that forms a right angle, that's the perpendicular part. Bisector, where it makes the right angle, is right at the midpoint. So this right here would be the midpoint of the segment, and the line that goes through it has to be at a 90-degree angle. I know there's a construction there, but we're gonna wait and do that after we've done the equation. So on 3/4 is where it was. Okay. So a perpendicular bisector, draw yourself a little picture up by the definition. You got a segment, call it maybe AB. You can make it horizontal, I don't care. And then make mark where you think the midpoint is and put the tick marks to tell yourself that's the midpoint. This can't be a line then, there has to be a segment. You can't do the midpoint of a line. Okay, and when you draw the line through that midpoint, it has to be at a right angle to be a perpendicular bisector. There's two parts to that definition. Makes a 90-degree angle and goes through the midpoint. So since we're thinking about writing equations, I'm going to skip the construction at the moment and go to writing the equation. Okay, how would we write the equation of the perpendicular bisector of this segment? So the ends of the segment are those 2 points. And I know I'm not graphing it accurately, but here are the 2 ends of the segment. -1, -3, and 7, 1. What point do I want my perpendicular bisector to go through? Yeah. The midpoint. How do you find a midpoint? All eyes go over there. Midpoint formula, is that second one down? Okay, so we have to find the midpoint, first step. Okay, find the midpoint of AB. The x plus the x divided by 2, and the y plus the y divided by 2. 6 divided by 2 is 3. -2 divided by 2 is -1. 3 -1. Okay, that's the point that we want our line to go through. That's the point we'll use in our equation. What slope do we want it to have? Do you want it to have the same slope as AB? No, to be perpendicular it needs to be the opposite sign and reciprocal. So what's the slope of AB? Don't know. Gotta find it. So find the slope of AB. Slope. Subtract the y's and subtract the x's. So 1 minus -3. 7 minus -1. 4. 8. 1/2. That's the slope of AB. What's the slope I want to use to make it a perpendicular bisector? Say it louder. -2. -2 over 1 or just -2? Okay. Do you understand the information we found? We had to find the point to go through, which is the midpoint. We had to find the slope to make it perpendicular to AB. Now write the equation of the line. The point it's supposed to go through and the slope are right there. Start with point slope. Convert it into slope intercept probably. So y minus -1 equals -2 x minus 3. I'm writing the equation with the point I want it to go through and the slope I want it to have. Then simplify it. Distribute. I'm getting y equals -2x plus 5. Did that come out right, or did I goof up? Am I good? What point do we want it to go through? Do we want it to go through A? Do we want the perpendicular bisector over here? No. We want it to go through the midpoint. So I'm using the 3 -1 for the point and the slope of -2. think we need to try another one of those. Questions though before?
No, we need to do another one.
Yeah, I'm sure we need to do another one. This is a part that students don't remember how to do, so I want to make sure we do another one. Got it? Okay. So here were the steps of that one. Let's get to another one. All right, here's another one. Write the equation of the perpendicular bisector for segment AB. A is the point 6, -3, B is the point 12, 1. Those are the endpoints of the segment. But I want the equation of the perpendicular bisector. What would be the line that would go right through its midpoint at a 90-degree angle? So what were the two things we had to calculate? Midpoint for the point it goes through, and then we had to work with the slope and fix it up to be perpendicular. So work on those two things. Worksheet, after I have you come up with the equation, I gave you a little piece of graph paper, and I want you to graph the segment and the line you came up with and see if it really does cut it in half. The reason you change it is because you want it to be perpendicular. This is the slope of AB. So are you going to use that slope when you write the perpendicular bisector? Are we ready to check? Not quite? Yeah, I want you to simplify it. That's the slope of AB. Okay, I end up with y equals negative 3 halves x plus 12 and a half.
All right, I got 13, so that was just round up.
Don't help. Okay, so the main mistake I saw was some of you were finding the slope and you got 2/3, but then you were using 2/3 in the equation. Why do we change it? Okay, because if you don't, you're gonna make a parallel and it's not gonna intersect it at all. So you need to change the slope to create a perpendicular. That's where you're gonna get mixed up. When do you change it, when do you not? Perpendiculars, you need to use opposite reciprocal slopes. Parallels, use the same slope. How many got that right? I didn't think everybody did, okay? Some of you are ready for the worksheet, some are not. Why don't we do a perpendicular bisector that's on the worksheet? Alright. So I did not do the construction, it's the same construction as midpoint. So if you have your supplies, you could construct using the midpoint, otherwise we'll try and remember to fill that in. You don't have to construct, but there is something you could do. Yeah, you don't have to construct.
So said I bet that we get
Okay, let's go to the back page and do a problem. There's 3 perpendicular bisectors that I put back there. Which one should we do?
28. Last one's
Hand them back. Hand them back.
228.
We're gonna do it.